Hey folks, this is a continuation of my video series that's looking at WebSockets, the very powerful asynchronous networking package for Python, which is itself a continuation of my intermediate Python series. Now, you don't have to have seen the entire intermediate Python series where we're making a Dropbox clone, but it's definitely worth going back for that if you want to learn about asynchronous stuff, and we do some asynchronous GUI stuff, but you don't have to have seen any of that to follow along with these videos. But you absolutely need to have seen the previous WebSockets video before this one, because in it we do all the basic kind of groundwork and an introduction to how you make a server, which is really fast, just these two lines, and then we get fancy with the client part, where instead of the usual thing where we would give an address that we want our client to connect to, we've got a port scanner that's going through all the IPs in a local network, and I can show you that. Let me set this to 40 here so it goes through, and so it's trying to reach me, but it's not. It's timing out. So we've got this effective port scanner that'll go through and cycle through until it hits a version of itself that it can connect to. And this hello yourself message indicates that we are now sending messages back and forth between the server and the client. But you'll notice that the port scanner just stopped. So that's a problem. We're going to need to address that. But while we're addressing that, let's address another problem that we haven't even hit yet. All of networking is built around a server-client relationship paradigm. And that is usually pretty useful, but not for our case. So if we have a client that connects to a server, and then we have another client that connects to that server, and remember, we're doing a Dropbox thing where we want to be able to share files between different machines when one of these files changes. So if a file on client 2 changes, and we want that change to now be copied over to client 1, we would have to copy it to the server and then to the client. And that's doable, but kind of inefficient, and I don't want all kinds of unnecessary network traffic on my network. So let's instead design this to be peer-to-peer, where it's going to just try to make connections with every instance of itself on the network directly, so that when a file changes, we can just send that file directly to the machine that wants it. So in order to pull any of that off, we're going to have to really rethink this structure, because we don't want this server-client thing where it really matters who's a server and who's a client. We just want everybody to be a server and a client so that they can make all these connections to one another and receive the connections. So when we want to create some really complex thing like this, this is when you step into the world of object-oriented programming, because we're going to create a object that is basically going to mask all of the relevant stuff inside of one object. So it doesn't matter to our program whether or not it's connected as a server or a client. It's all going to work the same way. It's going to like wrap all of the functionality into one package, so we can treat a server and a client connection identically. It'll be completely seamless to our program. So let's start off by creating a class that's going to be our super class, and we'll just call this the connection handler. And this is where we're going to stuff the bulk of our program stuff here. So we're going to need to know what the WebSocket is that we're handling. And we're going to need to know the host name of the connected machine. And we're going to need to keep track of the state. The state is so important in networking stuff. This is going to save us a lot of trouble if we keep track of the state throughout the execution of things. Now, this superclass is where we're going to put all our methods and stuff into, and we will inherit this into a server-specific handler. So now this thing just inherited everything that's inside of here. And we do need to have a server handler that's unique, because we're going to actually create these server connections in a different manner from the way we create a client connection. So the actual connecting part is specific, but after we've finished that initial connection, this is going to be identical to a client. So let's make the init method of this, which is whatever gets called as soon as we instantiate a server handler instance. We're going to expect to receive a WebSocket, and we'll just assign that now to the self WebSocket. So you see, when I click on this, PyCharm knows that I'm talking about this, because we're actually inheriting this into there. So that's all we really need to do to distinguish a server from a client here is to say, this is how you create it. You put the WebSocket into the self WebSocket. And now we can start to add actual methods and stuff for this to do. So like the first thing that I'd like to do is create wrappers for common methods, things that we're going to do a lot. So like if we had a function, like we're going to have a welcome function here. If we want to send a message to the connection, right now what we'd have to do would be like WebSocket send. And I know that all the data that we're going to be sending is going to be in JSON because we're just going to be sending serialized data. So we would have to first like take our message, or actually let's do this right. We would have to do a dictionary, and we would have to make that data and say that it is JSON dumps message, and then we would have to pipe this in here, and we would have to do this every single time we want to send a message, and that seems like that would get tedious. So let's just make a send function in here that's going to take a message, and here we'll just do all this stuff here where we're going to say that the data is equal to JSON dump S, which is the secure way to dump things. So whatever is passed to this send method as a message is going to immediately be converted into a JSON data serialized thing. So we can do the self WebSocket send of that data in here. So that only happens that one time. And now we can do self send, and whatever message we want to send will automatically be converted. So we can just do the dictionary in here, and like this will totally work. Although this needs to be asynchronous because we need to await that sending. We would have to await like this. Reminds me, I got to get into the habit. All of these methods are probably going to be asynchronous. In fact, I think all of them are. So we've got a way of sending data. Let's now make a generic way of retrieving the data. So we'll do receive, and it's not going to have any extra arguments there. So we'll take the message from self WebSocket. Gotta await this. Receive, and now that's gonna give us a chunk of things, and we want to now change that chunk into usable data. So we'll do the JSON load S of that message, and we should probably be capturing this in a try, except in case we encounter any kind of errors here. Use traceback to give us the full error. Let me do the same here for the send, because I am typing and talking at the same time, which means that I am definitely going to screw up something in here. So once we get our data here, we can just return that. And now we're actually able to start building out this welcome thing. So when a new client connects to us, we're going to expect the first thing that it does is to announce itself. So it's going to basically just give us a hello message with its name. So we're going to say that the greeting is await self receive. So whatever we get from that is going to use this function and spit back some useful JSON at us that's going to be turned into a dictionary, and we can just interact with that Pythonically. So we can do some checking on that data to make sure that we're getting the data we're expecting to receive. And by the way, this method is going to return a Boolean, and I can specify that. Oh, yeah, it's complaining because it's not actually returning anything yet. So that's a type hint thing that we can do just to make sure that we are going to be consistent with this. It always needs to be returning a Boolean of true or false. So we've got our greeting dictionary now that we can check to make sure that if hostname is not in the greeting, well, then this is not somebody that's connecting to us that we want to be talking to. This is somebody else that's just randomly hit us. We don't want to have anything to do with them. But now we also need to make sure that they're not trying to hack us. So let's make sure that the length of greeting hostname is not something insane. And if it is, then just return false. We're not going to deal with them. Now, if we get to this stage, then we think that we have a legitimate client attempting to connect to us, but we need to challenge them. So we're going to... The next videos immediately after these WebSocket videos are going to cover cryptography. And I'm just going to do like a real kind of brief overview of it here, where we're going to have a challenge that's going to have a special sequence of things that we're going to be using when we're hashing our password. So we're going to send this challenge now to the connected machine to make sure that it knows that we're also a legitimate person. Like the challenge here is going to have stuff that's going to indicate that we are a legitimate version of this software, so that when the machine sends its password, that's going to be reasonably secure, because it's going to be certain that this machine is who it says it is. Who it says it is. So we need to send this now. And because we've, like, this is why I started off doing this. Like, this is step one, is making it do all this dumping and loading and all this. Like, all I have to do is create a dictionary and pipe it in as self.send. And when this now goes through to the connecting client, it's going to use that challenge to create a hash of its password and send that to us. So the password is going to be await self receive. And once again, we need to verify that this is what we think it's going to be. And if the password's not in there, we don't want it. If the length of password is insane, we're not going to try to load that into our memory or do anything weird with it. For the purposes of this video, we're just going to use password as the password, but let's add a helpful reminder to ourselves to do the actual password stuff here. But right now, if we get past these two checks, let's assume that this is good and check now if password equals password. And if so, success. And let's return false if it gets past that check. So there are other things we need to do now. Like we need to set the state to connected. But remember how our register client handler here is going through this async for message in WebSocket, and that's how it's listening for any new communication from that. We need to set that up. We need to have a way for this actual connection to send us new information, or else this is a useless connection. So let's create a listener that's going to be exactly like what we have down there. So async def listener, and it's seriously just the same thing. Async for message in self WebSocket, and we're just going to print the message. But we're going to need to include some error handling here, because if the client gets disconnected, we are going to hit an error. So let's try and accept. And the most common exception we're going to have is going to be ConnectionClosed, when they just flat out disconnect from us. So we're going to add, well, for now, let's just say that we'll announce that. We'll say that enclosed from, and we'll give the host name, which, by the way, I just realized I didn't save when we got it up here. So let me do that right now. We'll save the host name to self.hostname. Okay, I was bouncing back and forth here. I want to make sure that I'm clear on what we're doing here. Now we've got this listener, And we've got this state here where we're connected and we're about to return true. But before we close out of this, we need to spin up this listener in its own asynchronous task so that even when we're finished with this welcoming, there's going to be an instance of our thing that's always listening for a new message from whatever just connected to us. So we do that very simply by using the Async IO get event loop and create task. And then we just stuff in SelfListener. And that's it. Like this one line here just did all of our background processing stuff for us. And this is really, really clever because when this connection gets closed, all we have to do is like basically just de-instance this and the task itself will disappear. So let's create a closer here. And we're going to hit this from a lot of different angles. So some of those might be broken. Yeah, whatever. If we use this close, we want to do is go to the self WebSocket, and it's going to have a close method built into WebSocket that'll make sure we totally close out that connection and don't try to persist it anymore. Now, one other thing that we need to do here, now that we've got this connection here, we need to add an instance of this connection to something that's going to keep track of it for us. Because the way that garbage collection works in Python is as long as you have some reference to the thing, it's going to keep happening. But as soon as you stop referencing it in memory, it's going to stop happening. So we need to create a collection that's going to keep track of all our connections. And there's lots of different collection methods in here. We're going to use the set collection type, which is like lists, but it's really strict. You can't have duplicates, and it's got a helpful remove function. So when we get to the process here, I'm trying to think where do we want to stuff this. Let's change this. Like we don't want to use this listing right here anymore, but we still want to have a register client. So when somebody does connect to our server at our IP and the port that we've specified, it's going to pass this WebSocket. So we're going to create a new connection using this whole server handler thing that we've created. And you see it's expecting a WebSocket. So let's pass in the WebSocket that we got from WebSockets. So now we call that connection listener. We call the welcome. But remember, this is a Boolean. It's returning a true or a false. So we can await or if await it. And if this is true, then we know that we've definitely got a solid connection here. And we want to add this to our collection of connections. So we just add this connection. And this process right here just did that whole memory thing that I was telling you about, where this connection is now going to persist in memory inside of our connections collection. God, that's getting confusing to say. And the listening event that we started up for it will continue too. But if they do disconnect, we're going to need a Unregister function here, which is going to take any connection. And the first thing it's going to do is try to close the connection with that close method that we made. And then it is going to try to remove the connection from our connections. Let's put that in a try. And it's as simple as connections remove connection. Yeah. So let's just do a generic print on that. So let's go back up to where we're closing this. So if we get to this is when it's just a normal connection closure here. And we'll also accept for any kind of weirdness. Just do traceback, print exec. But whatever breaks us out of this, we want to finally do a unregister of ourself. Oh, I gotta await that. And this is one of the really, really cool things about working with objects like this is we're able to say this specific instance of this thing. We're just passing the whole thing into this unregister, and that's going to be something that the unregister can use. Like it'll work like this. It's really cool that you can do that. So we're passing the whole instance of ourself to unregister, and when it gets down here, it's going to try to close it to make sure that it's closed, and then it just removes it from the connections set. And that's it. Like that's when the it gets removed from memory, and that task that we had created in the background for the listener, that also just disappears. So we're not going to have any kind of problems with like memory getting out of control, like a memory leak, where we've got closed connections that are still running in the background or something like that. Like this is just closing it out. And while I'm thinking about it, because of the way we're going to be hitting these closes, let's just set the state to disconnected, just to really keep track of our states. Like there's something that just occurred to me that might break later if we don't do that there. But this should be a relatively instantaneous process. But that all should work. But now we got to actually do the client part in order to test that. So remember up at the very top of our connection handler, because everything we've been doing is inside the connection handler. Like this is the same thing that we're going to use for clients and servers. We gave it the variables for the WebSocket, the hostname, and the state. But we're going to need the URI that we're forming down here in the port scanning in order to make the client connections. So when we inherit into a client handler, the connection handler, if we create the init for this and get the URI, if we this self URI, we're able to do that. Like it's just going to automatically create this self URI variable. But there's going to be a problem here when we try to use that up here. So we've got our welcome. Let's do the other end of this now, where it's the client connecting, which we'll call the login. This isn't going to return anything, so we need to first establish our connection to the URI that we've assigned. So let's await self WebSocket. So we actually need to create the WebSocket when we're going in from this way. So is going to be await WebSockets Connect to self URI. But you see that there is no URI that's in this. So make sure that even though we're not using this URI in the server function, since we still are going to be using it, we need to have it inside of this connection handler. So now that works. It got rid of the error. Remember that we found the problem with the timeout. Like there is a timeout argument that we can give to this, but WebSockets just completely ignores it. So instead of just doing this straight await WebSockets Connect, we actually want to stuff this inside of an Async IO wait for, which lets us now set a timeout of 3 seconds. And in doing so, we're going to immediately start to encounter errors. So when that times out, we'll hit our connection timeout error that we created in the last video. So we can print this out now and say like connection timed out to, and here we'll just put in self URI. And from here we'll just return, and let's add in some more error handling, like the refused error. We'll just let us know that the connection refused to this URI. And remember, we're just hitting a whole sequence of basically random IPs here in our local network. We're expecting this to fail 99% of the time. So we can just be kind of general about this. We'll just make sure that every kind of exception here is just returning because screw it, we don't really care. So it just bounces right back. Didn't work. But if we do make a connection and we didn't hit an error, then we need to go through this whole welcoming process where we greet the server by letting them know who we are. Okay, so this is right. We're going to await SelfSend, and here we'll just send a simple greeting that... oh, that's right. We put the host name in there, and hello, my name is... And then we expect the server to take that and then stuff it in here and then send us a challenge. So let's say that the challenge is equal to await self receive. And now we need to do all the same kind of error checking here, where we're checking to make sure that the challenge is in challenge. And if it's not, return. And let's make sure that the length of the challenge inside of challenge is not greater than 1024, or otherwise we should return. And now we've got our challenge. This is where we would password hashing goes here. And we'll just for now send off a... Oh, you know what? We should also send the host name of the server here, because the client is going to need to know that, and this is a good place to do that. So I think I just figured out why I'm having so many typos. I'm kind of leaning like this, looking at the camera, and if I just sit the way I usually sit, I should probably type better. So we're going to just say that the password is equal to passwords. We want to create a dictionary of this, though, because we're going to do all kinds of complicated stuff when we're done here. And remember that in the challenge, we're now looking for a host name. So let's do the tests here. If the host name is not in challenge, then return, or length of challenge host name is greater than 1024. All right, so let's send this password now. And now we need some sort of a way to know that this was successful. So we should probably await send a simple connection authorized. And maybe here, instead of just returning false, since we got to this stage, we're pretty sure this is a program like ours, but it gave us the wrong password. So let's actually give them a useful message to let them know that the connection unauthorized. All right. So up here now, we're sending off our password, and we need to now await confirmation. And once again, we got to check if actually, you know what, at this stage, we don't need to do the whole checking thing. Like we're pretty sure this is legit if we got past the challenge and everything. So we can just do a simple get. So trying to think how to phrase this. The confirmed is just going to be confirmation get confirmed or connection. So now here we can check if confirmed equals, what did we say, authorized? Then, yay, we've done it. We're successfully connected, but now we've got the same problem here that we had before where Okay, well, now we've done that, I guess we can set our state to connected, but this connection isn't actually going to do anything unless we spool up a listener for it. Now, we're going to do it slightly different for this because of the way we're doing this port scanning thing, and we're just trying to connect to a whole bunch of different things. We want to really make sure that this connection is solid before we do any of the stuff with the listener and throwing that into the task and all that stuff. So we're going to actually return from here. And I'm not worrying about the unauthorized right now. We'll deal with that when we do the actual cryptography. And down here in our port scanner, like we can get rid of all of this. Like we don't need this anymore. We've got all the error handling inside of that, so we probably don't need to put this in a try. All we need to do is say that our connection is going to be the client handler, and here it's expecting URI, so we give it the URI. And now we await the connection login. So when it's finished with this, it's going to return, like no matter what, if it connected to a IP successfully, if it failed at some of the handshaking or whatever, it's always going to return from this. The thing we can use to check to see if this connection was actually good is to check the state of this connection. So if the connection state is equal to connected, then we know here in this port scanner that it is successful. So we want to add our connection now to our collection. So our connections add connection, and it occurs to me that I should probably add some dialogue up at the top so we know when things are connecting to places, but yeah. We've added that to our collection, and now we can add the that listener, the same exact listener code that we're using in the server. We can add that now to our event loop. So we do the Async IO, get event loop, create task, ConnectionListener, and now at this stage, the client and the server are identical as far as our program is concerned because they've got all the same code past this login handshaking. Like it's going to be identical across them all. Like I realize that I just spent like 30 minutes or something like this making all this other stuff that seems very, very much like they are not identical, but that's what we were working on, the wrapper to make them look identical. Past this point, everything is going to be identical across the board, and that is the really cool thing that we're doing here. And because of the way we're structuring this, we're getting around the async problem that we had before with our port scanner getting stuck when it made a connection. So this should now work. Let's test it. I'm certain that there's going to be some errors along the way. Let me add little notices so we know when something connects to us. So like here at this, let's do a print new connection from whoever this is, and a up in the login here, when we set this connected here, we'll do the same print connected to hostname. Now remember, we're building this all into one app. We've got the server and the client all going to be in one app. So it's all built into this networking document. And I've got a testing client here where we can test them individually here, where I'm just importing the networking and using this port scanner here. I want to also distinguish these two. So remember the networking, it's getting the hello, my name is, and it's figuring this out as soon as you import this file. It's figuring out the host name up at the very top by getting the host name from the socket. We want to actually differentiate this because they're both running on my machine. It'll just say my machine's name for both. So now we'll know when the client, which one's the client and which one's the server. Let's give this a shot. All right, so that is basically the server up and running. It didn't give me any errors. Let's start the client. It's, oh, I have it going through. Well, okay, that's good. We were getting the timeout messages. Oh, okay, that's interesting. I know exactly what I did wrong here. Down here where I call the unregister, I forgot to await this. But that's interesting that it immediately jumped to, there was a problem, I need to unregister this. And we're suppressing so many different messages that we didn't actually get an indication of what the problem was. Let's see if the server got anything. New client. Oh, a new connection from client. So it did get that. I wonder why it decided to quit. Because we're telling it to, like, this is the only place we're calling the unregister from right now. Is it because I'm using this finally? Like, I guess. Because it should be stuck in this loop forever. You know what? Let's only call the await unregister when we know we've definitely hit an error. Just for now while we're doing all this. So let me change the port scanner to jump immediately up to the right range. That's already there. Connected to none. We forgot to save the name of the host. Here's our login. Yeah, we got the host, but we didn't save it. All right. Let's try this again. Connected to Thoth. All right. And now it's moving on with the port scanning. So like this was the problem before, right? The port scanning did not persist after we made a connection, but now this connection is still here. And you notice we're not getting any of the disconnect messages that we created. And we can now test this even further. Like let's do a kind of a, we're going to be sending a lot of data between all of these. So let's just make the bones of that, which is going to be a status update. Status, where we're going to want to check for every single connection that we have, let each connection know what's going on with us. So, I'm trying to think how to structure this. Let's first let us on the local machine know that we're updating the status. So, and the thing that we're going to be paying attention to now is the length of our connections set. So let's just say updating status and either a 1 when we're connected or a 0 when we're not. And for connection in connections, if this connection state is connected, well, let's send a little message to let them know that what's going on with us. So we'll say connection send. Here we'll just say let's give it our name so we'll know which machine is, or which instance is running here. And we'll say connections is once again just the length of connections. So we can now add this to our event loop, just using a create task here of status update. But on the client, we're gonna have to do something tricky here. This run until complete is going to take precedence in a weird way. Like this is actually kind of informative, so I'll let it run into this problem. So, oh yeah, when we actually need to make sure that this is going to be a loop that it'll persist. So while true, do all this, and at the end of that, we'll await a sleep of 10 seconds here. So we'll know when it triggers, and we'll see the messages when we get messages going back and forth. Let's see what happens. So see, updating status right now, there's no connections. And if we did connect there. Oh shit. All right, I know what's going on here. Async IO is amazing. Let's just, before we even deal with this, let's appreciate just how amazing Async IO is, because this is so much easier than any other programming language out there. But sometimes it leads us into some weird territory. And I know exactly what territory we're in right now. So when the WebSockets serve method is getting a connection, it's going to our register client, and it's spinning this off as its own process. And when we're doing all this, it finishes that process, so it closes everything else behind it. We need to do a while true. Actually, let's put that underneath where we assign the connection here. And let's await async IO sleep. Just leave it as that. So just by doing this now, we're going to have a persistent process that's going to be spun off by WebSockets. Okay, so this is kind of out of our hands. It's WebSockets doing this register handler thing. So we need to make sure that we're while truing here, but we don't want to just keep trying to make this connection. So let's set a variable for doneness, and if not done, then we do this. And if we succeed, change done to true. And now this should solve this particular problem. Let's give that a shot. Got the new connection. Gotta wait for it to try to send its updates, and it did. Yay, no error. Let's see. Okay, so over here, we are getting the message. So our connections are persistent. We've got to account for them, and they're talking to each other. There's a whole nother message. Like, we've got two messages now between our application. But you'll notice that we're not getting the return back from the client, because the client's also supposed to be saying, hi, my host name is client and my connections are 1, but we're not getting any of that. It's not even giving us the update status number here. And the reason for that is super weird. So we're starting this client things here using a run until complete, which is exactly the way that we're starting the server thing. But for some reason, because of this, in this context, it's getting a weird prioritization thing where it just doesn't seem to be hitting this at all. Like, I don't think that this task has been hit, or else we would have seen at the very beginning updating status the same way we saw at the very beginning of this one. Like, that was before any connections. The first thing we got was update status. So if we just change this to a create task, that solves the problem. So restart everything. All right, so it made the connection. It's continuing to do its... Okay, yay, we're getting the messages, and it's updating its status. So we got the message going back and forth now. So now it's all happening right now, right? We got messages that we're listening for, messages that we're sending, and it's still doing the port scanning where it's trying to find other connections to make. So it's all happening. I just thought of an error that we're probably hitting, because I'm always forgetting to put in these awaits. So we're closing the connection. Are we awaiting it up here? Oh, I forgot here. I knew I'd forget this somewhere. So let's just take a moment now to appreciate what we've done, because I realize that I'm ending this video exactly where I ended the last video, where we got a client and a server, and I was talking about how we're going to be getting away from that paradigm, but we really have, like, all the things that we've done in this video were the necessary steps to wrap the server and client stuff into one package. So now going forward, we don't have to worry about who's a server and who's a client. They're just going to be entirely seamless as far as our program's concerned, because we've got all that stuff built into the same package, and it's just going to treat the connections the same exact way. I don't know if I can convey how cool that is, but it's really cool. Like this is a great way of working. And I know that a lot of people have some hesitancy about getting into object-oriented stuff, and they get really worried as soon as they see the class start to float around. But it's nothing to worry about. I mean, honestly, everything's already an object in Python. We're just making our own this way. Like that's all it is. We made our own object, and it's combining the server and client stuff and the way that we connect those together. Like that's it. I'm debating whether or not I should go through and try to explain everything that's gone on, because I know I've just bouncing around. I hope that you've been able to follow this. I hope this has been helpful. And I sincerely want to thank my 2 Patreon patrons for their patronage. And if you like what we're seeing here, please let other people know about this series. Like, I'm not going to ask you to like and subscribe or anything like that. I'm just a little depressed with how much effort I'm putting into these. Like, none of my usual subscribers give a shit. Like, nobody cares about this. The last video got like 50 views in the last month. So if you know anybody that's going to be even remotely interested in WebSockets, please let them know so that we can get some of these views going. Because, man, this is a lot of work for 50 people to see. Take it easy, folks.